इस आदमी सारा घपला किया है।
अभी कैसे देंगे
इसका अवार्ड नहीं, अवार्ड की 265 की
1200 की करेंगे।
हाँ 1200 की है, में से 265 की, उसको पता लगा तो इसने 265 कर दिया। इसने अवार्ड डेट भी 265 की दी। हमारे स्टूडेंट कितने थे एनरोल?
हमारे 200 कुछ 65 ही है शायद। 265
सर ने 198 की लिस्ट बताई जो सर ने एमएस कोड एमएमपीसी कोड की है।
तो कर ही नहीं सकते सबमिट।
हम 265 तो कर ही नहीं सकते।
गड़बड़ करिए हम लोग।
ये भेजेगा वो
265 तो हो ही नहीं
वो सर मैं काट दूंगा।
काट देंगे।
हाँ सर मैं काट दूंगा।
कैसे काटेंगे?
काटेंगे ये तो क्लेमेंटी नहीं काट लिया, हमारे नंबर ऑफ स्टूडेंट्स एनरोल्ड नहीं है इतना। अरे वो तो एलएमएस में पता लग जाएगा कितनों ने नहीं भैया मनीष जी, एलएमएस में पता लग जाएगा एमएमपीसी 2 और 3 के कितने स्टूडेंट्स ने असाइनमेंट सबमिट किए। क्या बात कर रहे हो यार, एलएमएस में लॉगिन करो।
मेरे पास है लिस्ट।
जाहिर सी बातें होगी। एमएमपीसी के सिस्टम पे इस पे जाकर सिस्टम एलएमएस में जाकर आप ये देखो ना एमएमपीसी 2 और 3 के कितने स्टूडेंट्स हैं निकाल लो। तेरा होगा।
हेलो अंकुर जी, सब ठीक है? ठीक है 15 का मैं चालू करवा रहा हूँ। ठीक है ठीक। बोलिए तो मैडम को सारे काम मनीष ही करेगा ना आपसे बेटा के। तुमने मुझे क्यों टेक्निकल आदमी में तू क्या ये तो सॉल्यूशन बता बस। तो ये मैडम को बोल देता है एक बार। चल मैं बोलता हूँ मैम के बोलेंगे और बैठ जा वो उसे ना निकल पा सकते इसी तरह से वो निकलेगी मगर सारी बैटरी खराब हो जाएगी, फिर बैटरी लगेगी दोबारा। सारी कार्ड जो उसके अंदर हैं वो सारी फैली नजर आएंगी, बैटरी लगेगी पाएगी दोबारा सारी कट जाएगी। उसका रास्ता बस वही है। कितने मीटर चाहिए बताओ?
14
15 करते सर मैं 12 जाऊंगा, बंद कर दूंगा। आप स्टार्ट कर दीजिए।
मैं कैसे स्टार्ट करूंगा? तो कैमरा आ रहा है
और इसमें क्या करके जाता लड़का है बस खत्म।
हाँ कौन सा है? Section of quantitative analysis for managerial application. MLC 005. I'm your academic counselor, Saxena. We have just one, and we are continuing. And yesterday we discussed about the concepts of discrete probability distribution. And today we continue continuous probability distribution where we left yesterday. Today we will be starting with probability distribution of random variable. A description of the value of random variable along with the corresponding probabilities is called probability distribution of the random variable. If variables of takes value x1, x2, xn, and we have probabilities p, p2, p3. Aware of that above probability distribution of x is defined only when px1 is greater than or equal to 0 and the summation of all pi's, that is all probabilities, x equal to 1. And we have probabilities The mean in mean random variable is denoted by mu, and it is summation of xi pi. Similarly, we have variance. Variance has a specific formula, that is sigma square equal to summation of product of x square pi minus mu square. Mu square is mean. That is mean square, and standard deviation is under root of variance. And variance is defined as the expected value of the square of the difference between the random variable and its expected value. We take up an example to understand how these formulas are applied to a particular problem. Suppose we have to find mean, variance, and standard deviation of the number of heads when coins are tossed. So initially we have to write up the sample space, and that is TT, T, TTH, THT, THTT, THH, HTH, HHT, and HHH. That means a total of 8 outcomes are available with us. But these are the possible outcomes. Suppose we denote X as number of heads in tossing the 3 coins. So number of heads may be no head, 1 head, 2 head, or 3 heads. That means X will take a possible value of 0, 1, 2, or 3. To calculate Px is equal to 0, we have to find the probability of getting no head. So that means that will be a case where no head is present, then all the tails are present. That is, we can see there is only one outcome out of the 8. That means its probability will be 1 by 8. Now we move on to Px equal to 1. Here, getting one head is in question. That means it is possible under 3 conditions: H, TT, or THT, or HTT. That means the outcomes are there. Total number of outcomes are 8. The probability will be 3 by 8. Similarly, for P, X is equal to 2. That means we want probability of 2 heads: HHT, HTH, TTH. In that case, it will be 3 by 8. And for all the 3 heads, it will be 1 by 8. So we will put this into the tabular form because we have to calculate mean, variance, and standard deviation. So X has the value of 0, 1, 2, 3, and the respective probabilities is 1 by 8, 3 by 8, 3 by 8, 1 by 8. Now, here we have to see that the summation of P1 as well as Pi is should be 1. So here we can see that when we are going to add all these 4 outcomes, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 will be equal to 8 by 8, that is 1. That means our calculation is correct. Then we can proceed further to calculate mean. That is mean. Mean is the product of xi pi. So we will be multiplying 0 by 1 by 8 plus 1 by 3, 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. This comes out to be 3 by 2. That means its mean is 3 by 2. In case of variance, we have to calculate the summation of x square I pi minus mu square. Mu square is mean. So we will be squaring 0, 0 square is 0 into 1 by 8 plus 1 square is 1, 1 into 3 by 8 plus 2 square is 2, 4, 4 into 3 by 8 plus 3 square is 9, 9 into 1 by 8 minus 3 by 2 whole square. That comes out to be 9 by 4. So after calculation, it comes out to be 3 by 4. And for standard deviation, we have to under root. That means we are going to get root 3 by 2. Now we move on to Bernoulli's theorem. Let there be an independent trials in an experiment, and let the random variable is denoted by x. So x denotes the number of successes in these trials. The probability, as we know that probability of success plus probability of failure is 1, as probability of success is denoted by P and probability of failure is denoted by Q. That means P plus Q equal to 1. We have a formula to calculate the probability under this condition. So that is Fr is equal to NCR P raised to the power R into Q raised to the power N minus R. One important thing is that how to calculate NCR. NCR basically is equal to n factorial upon r factorial into n minus r factorial. And we should be careful in that if we get n minus r equal to 0, so 0 factorial is 1. 0 factorial is not 0, 0 factorial is 1. Similarly, as we did earlier, x can take up the value of 0, 1, 2, 3 till r, and we have to calculate the values of px, q raised to the power n, and p q raised to the power n minus 1, and c2 p square q raised to the power n minus 1. Similarly, till the last. This is binomial distribution, and normally we apply this binomial distribution coin tossing and success failure situations. What are the conditions to apply binomial theorem? The experiment is performed with fixed number of trials and performed for finite trials. Each trial must give either a success or of a failure or a failure. The probability of a success in each trial is same. The mean will be equal to and the product of n into p. Variance will be npq and the standard deviation will be under root of npq. Poisson distribution is applicable to events occurring randomly over time and space. Present distribution of several random variables like to count the number of defects of a finished product, to count the number of deaths in a country by any disease or natural calamity, to count the number of infected plants in the field. These are the conditions where Poisson distribution is applied, can be applied. To count the number of bacteria in the organism of a radioactive decay in atoms, to calculate the waiting time between the two events. Poisson process corresponds to a Bernoulli's process with a very large number of trials, that is n, and with a very low probability of success, that is m by n, in any trial. That means there will be a constant lambda which is equal to n into p, where r is the number of successes, and its formula is PR is equal to e raised to the power minus lambda into lambda raised to the power r upon r factorial. What are the properties of Poisson distribution? The events are independent. The large number of successes in the given period of time alone can occur. No two events can occur at the same time. Poisson distribution is limited to when the number of trials is indefinitely large. The mean, and in that case, mean is equal to variance is equal to lambda. The lambda is n product of n into p, where lambda is a constant. The standard deviation in this case also is equal to the square root of the mean. Suppose we take up an example. If 3% of electronic units manufactured by a company are defective, so that means B will be 3 by 100. Find the probability that in a sample of 200 units, that means N will be 200. Less than 2 bulbs are defective. So in this case, we can see that P probability is too small and N is too large. So here, this is a case of Poisson distribution. That means we will find lambda, which is mean. It is the product of N into P. This comes out to be the product of 200 into 0.03, which is equal to 6. Now we apply the Poisson distribution formula, that is PR equal to e raised to the power minus lambda into lambda raised to the power r upon r factorial. So we have to find the probability of less than 2 bulbs are defective. That means probability x less than 2. In that case, we have 0, probability of 0 plus probability of 1 defective bulb. We will calculate it. And as I told you, 0 factorial is 1. So 0 factorial is 1. So this will be anything, any number raised to the power 0 is also 1. That means 6 raised to the power 0 is 1. 0 factorial is 1. That means the solution will be e raised to the power minus 6. And in the second case, 1 factorial is 1. Any number raised to the power 1 is that number only. That means it will be a product of 6 and e raised to the power minus 6. We get, we know that the value of e raised to the power minus 6 is 0.00247, and we will multiply it by 7. 6 plus 1, because we will be taking e raised to the power minus 6 common. We get the product, or we can say the solution is 0.01729. That means the probability that less than 2 bulbs are defective is 0.01729. Now we move on to unit 7, that is related to continuous probability distribution. Here, variable of interest may take any value within a given range. This type of random variable, which can take an infinite number of values, is called a continuous random variable. Probability distribution of such a variable is called continuous probability distribution. Here we will be talking about normal distribution. Normal distribution is the most versatile of all the continuous probability distribution. It is found to be useful in statistical inferences, characterizing uncertainties, many real-life problems, processes, approximately other probabilities distribution. We will see, first of all, what is normal distribution in statistics. Normal distribution is a continuous probability distribution that is symmetrical around its mean. Most of the observations clusters around the central peak value, and the probabilities for values further away from the mean taper off equally in both directions. It will be a bell-shaped curve. Probability distribution, function of normal distribution, is given by fx equal to 1 upon sigma under root 2 pi into e raised to the power minus 1 by 2 within bracket x minus mu by sigma whole square, where x value of x lies between minus infinity to infinity. The real world phenomena that actually follows normal distribution. We are having three examples over here: birth rate of babies, height of males, and related problems related to blood pressure. What are the properties of normal distribution? In a normal distribution, the mean, mode, median, all are equal. The total area under the curve should be equal to 1. The normally distributed curve should be symmetric at the center, and there should be exactly half of the values on the right side of the center and exactly half of the values on the left side of the center. If we plot fx versus x, this gives a normal curve, and the area under the curve gives us the probability. Normal distribution is symmetric about the mean, and the area on each side of the mean is 0.5. The empirical rule states that 99.7% of the data observed following a normal distribution lies within 3 standard deviations of the mean. 68% of the data falls within 1 standard deviation, 95% of the data lies within the 2 standard deviations, and 99.7% within the 3 standard deviations above the mean. The formula for calculating z-score is z equal to x minus mu upon sigma, where x is the raw score, mu is the population mean, and sigma is the population standard deviation. The formula to calculate z-score is simply the raw score minus the population mean divided by the population standard deviation. That means we can say z is equal to x minus mu upon sigma. All these three values will be given in the problem. We have to just identify. The normal distribution describes continuous data which have a symmetric distribution with a characteristics bell-shaped curve. Binomial distribution describes the distribution of binary data from a finite sample. We can see that this graph is like a bell shape, and at the center it is the mean. 50% is on the this side, right side, and 50% on the left side. We take up an example to understand how it works and how the things are calculated, how the probability is calculated under normal distribution. A radar unit is used to measure speeds of car on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour. That means mu is 90 kilometers per hour and a standard deviation of 10 kilometers per hour. That means if sigma is 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? We have to calculate the probability when x is greater than 100 kilometers per hour. That means here what will be calculating? We have to calculate z. Here x is 100 and z will be 1. 900 minus 90 divided by 10. 10 by 10 is 1. That means we have to calculate how to write it mathematically. P x greater than 90 is equal to probability z greater than equal to. That means we have converted the problem of x into now z. That means it will be the total area minus area on the left of z equal to 1. Z, value of z can be taken from the table of normal curve. Its value is 0.8413. After subtracting it from the 1, we get 0.1587. That means, what are the characteristics of standard normal distribution? A z-score of standard normal distribution is a standard score that indicates how many standard deviations are away from the mean as individual value x lies. When z is positive, the value is greater than the mean. If z is negative, the value of bell-shaped graph of normal standard distribution. And we have to be careful that this graph, you can see to the blue line. It seems that blue line is somewhat away from the x-axis line. This graph line never touches, this blue line will never touch your x-axis. It's always above x-axis. Usually happenings in the real world follows normal distribution. This enables researchers to practice normal distribution as a model for evaluating probabilities linked with real world scenarios. Basically, the analysis includes two steps: converting raw data into the form of z-score using the conversion equation, that is z equal to x minus mu upon sigma, and finding the probability after the raw data is transformed into z-score. Then, with the help of standard normal distribution table, I said earlier, or normal distribution calculators available online to find the probabilities linked to z-score. How this probability is found? After the raw data is transformed into z-score, then with the help of standard normal distribution tables or calculators available, the value of z is calculated. Now we take up another example to basically understand. For some computers, the time period between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. That means mu is given to us and standard deviation is given to us. Achal has one of these computers and needs to know that the probability time period will be between 50 to 70 hours. So that means here we can see that from the problem, mean is 50, standard deviation is 15. We are given two values of x, that is 50 and 70. So similarly, we will be calculating two values of z. Now the thing is that what are the steps to be followed? We have to find the probability that the value of x lies between 50 and 70. That means mathematically it will be denoted by probability 50 less than x less than 70. Now we will be transforming this equation z equal to x minus mu upon sigma. When we put up x equal to 50, we get z equal to 0. And when we put x is equal to 70, we get z equal to 1.33. We have to find the probability of 50 less than x less than 70, and transforming it in the case of z, it will be probability of 0 less than z less than 1.33. That means our area will be between 0 and 1.33. The area on the left of z is equal to 1.33 minus the area to the left of z equal to 0. So area to the left of 0 is 0.5, and area under 1.33, what we get this value of 0.9082 from the table. So we get 0.9082 minus 0.5, which comes out to be 0.4082. We can say that the probability that Michael's computer has a time period between 50 and 70 hours is equal to 0.408. We take another example. Most graduate schools of business requires applicants for admission to take the Graduate Management Admission Council's GMAT examination. The scores on the GMAT are roughly normally distributed with a mean of 527, that means mu is 527, and a standard deviation of 112, that means sigma equal to 112. What is the probability of an individual scoring above 500 on GMAT? That means we have to calculate probability x greater than 500. You know, mu as 527, sigma is 112. We have to calculate z score. This comes up with negative part, negative 0.24107. So when we will be plotting this on a graph, this graph is drawn by freehands. At the center, its value is 0. On the left side, you can see it's minus 0.24. That means you have to calculate the value of x greater than 500. The region will be on the right side. In that case, to calculate the value of probability z greater than equal to minus 0.24, that will be 1 minus 0.4052, which comes out to be 0.5948. This example is related to the average number of acres burned by forest and range fires in a large New Mexico county is 4,300 acres per year with a standard deviation of 750 acres. That means its mean is 4,300 and its standard deviation is 750. The distribution of the number of acres burned is normal. What is the probability that 2,500 and 4,200 acres will be burned in a given year? Here, mu is 4,300, sigma is 750. So we have to calculate, so add two values, 2,500 and 4,200. We get, for 2,500, we get z equal to minus 2.40. And for 4,200, we get z equal to minus 0.13. When we plot this on the graph is something like this. So we have to calculate the probability. The probability 2,500 less than x less than 4,200. We put this value, convert this value in terms of z. This comes out to be probability of minus 2.40 less than z less than minus 0.13. Putting up the values from the table, we find that this comes out to be 0.4483 minus 0.0082, which is equal to 0.440. This is how the calculations under normal distribution are done. In short, we can say that exponential distribution is found to be useful for characterizing uncertainty in machine life, length of telephone calls, etc. Normal distribution is found to be useful for characterizing dimensions of machine part, heights, weights, etc. These are the applications where it can apply. Now we move on to Unit 8, This is related to decision theory. A necessary condition for the existence of a decision problem is the presence of alternate way of action. Each action leads to a consequence through a possible set of outcomes, the information on which might be known or unknown. One of the several ways of classifying decision problem has been based on this knowledge about the information on outcomes. Decision making can be under two conditions where you are certain about the event or you are not certain. That means you are under uncertainty. In case of certainty, the information on outcomes are deterministic and are known with certainty. And in the case of uncertainty, the information on outcomes are probabilistic, with the probabilities known or unknown. Depending on the planning horizon under consideration, as also the nature of decisions, we have either a single stage decision problem or a sequential decision problem. We have to calculate marginal analysis and decision what are and its decision theory approach. Marginal analysis for solving such single state problems. Here what we do. For sequential decision problems, the decision tree approach will be used. In both the marginal analysis and decision theory approach, we will be using expected profit as a criteria for our discussion. Expected monetary value, in short it is EMV, does not take into account the decision maker's attitude towards risk. Preference theory provides us with the remedy in this context by enabling us to incorporate risk in the same setup. The other problem with expected monetary value is that it can be applied only when the probabilities of the outcome are known. That is limitation. For problems where the probabilities are unknown, one way out is to assign equal probabilities to the outcomes and then use EMB for decision making. However, this is not always rational, and we will find other criteria are available for deciding on such situations. Marginal analysis, this is a technique which is widely used in business decision making and ties together much of economic thought. In any situation, people want to benefit, maximize their benefits. The net benefit is total benefits minus total cost. What are the control variables? To do marginal analysis, we can change a variable such as the quantity of a good you buy, quantity of output you produce, or the quantity of an input you use. This variable is called the control variable. Marginal analysis focus upon whether the control variable should be increased by 1 unit or not. What are the key procedures for using marginal analysis? We have to identify the control variable at the initial stage. Secondly, we have to determine what the increase in total benefits would be if one more unit of control variable is added. This is the marginal benefit of the added unit. Determine what the increase in total cost would be if one more unit of the control variables were added. This is marginal cost of the added unit. If the unit's marginal benefit exceeds its marginal cost, it should be added. What are the key procedures for using marginal analysis? Remember to look only at the changes in the total benefit and total cost. If a particular cost or benefit does not change, ignore it. And why does this work? Because marginal benefit is equal to increase in total benefits per unit of control variables. That means we can say that change in TR upon change in QCV is equal to MR. If the CV is control variable, that means one change in quantity of control variable. Marginal cost is equal to increase in total cost per unit of control variable. That is MC equal to change in TC upon change in QCV. So change in net benefits is equal to marginal benefits minus marginal cost. Why does this work? When marginal benefit exceeds marginal cost, net benefit goes up. So the marginal unit of the control variable should be added. Now comes the problem formulation. A decision problem is characterized by decision alternatives, states of nature, and resulting payoff. The decision alternatives are the different possible strategies the decision maker can employ. The state of nature refers to future events not under the control of decision maker, which may occur. States of nature should be defined so that they are mutually exclusive and collectively exhaustive. Influence diagram. This is a graphical device showing the relationships among the decisions, the chance events, and the consequences. The square or rectangles depict decision nodes, circles or ovals depict chance nodes, diamonds on the figure depicts consequences nodes, and lines and arcs connecting the nodes show the direction of the influence. Payoff tables. The consequences resulting from a specific combination of a decision alternative and a state of nature is a payoff. A table showing payoffs for all combinations of decision alternatives and state of nature is a payoff table. Payoff can be expressed in terms of profit, cost, time, distance, or any other appropriate value which is into the consideration. Decision tree is a chronological representation of the decision problem. Each decision tree has two types of nodes: round nodes, which corresponds to the states of nature, while square nodes corresponds to the decision alternatives. The branches leaving each round node represents the different states of nature, while the branches leaving each square node represents the different decision alternatives. At the end of each limb of the tree are the payoffs attained from the series of branches making up that limb. What are the decision making without probabilities? Three commonly used criteria for decision making when probability information regarding the likelihood of the state of nature is unavailable. In that case, we apply optimistic approach or conservative approach or minimax regret approach. Optimistic approach would be used by an optimistic decision maker. The decision with the largest possible payoff is chosen. If the payoff tables were in terms of cost, the decision with the lowest cost will be chosen. In case of conservative approach, it would be used by a conservative decision maker. For each decision, the minimum payoff is listed and then the decision corresponding to the maximum of or the minimum of payoff is selected. Hence, minimum possible payoff is maximized. Now we move on to block 3, that is related to sampling and sampling distribution. Here, 4 units are there. So we will be starting with sampling methods. When one is interested in measuring some attributes of a large or finite group of elements by studying only a part of that group, that means we can, in short, say something related to sample, something in our mind will come there. So we are talking about, we are thinking of or something as sample. This process of inferring something about a large group of elements by studying only a part of it is referred to as sampling. Example, take up an example of Bank of India. Measure the level of employee motivation. We administered a questionnaire to 250 employees from the different branches and offices all over the country out of its 30,000 employees. Now, We will be talking about some definitions, words or phrases what we will be using in sampling. Collection of all elements about which some inference is to be made is population. Any characteristics of a population will be referred to as parameter of the population. Some population parameter is inferred by studying only a part of the population, that is the sample. And any characteristics of a sample is called its statistics. We take up this what we said right now. The whole yellow rectangle depicts the parameter, which includes motivation level of the population, and it includes 30,000 employees, which is its population. The blue mark is 250 employees, which is the sample, and the statistic will be on this the motivation level of the sample, and the Celsius part on is the complete enumeration of the population. These are some of the symbols what we will be using throughout. We will be talking about two things: population and sample. So we have characteristic symbols for that. If we are talking in terms of population, it is a parameter. Population size is denoted by capital M. Mean is denoted by mu. Population standard deviation is denoted by sigma. And population proportions are denoted by capital P. And if we talk about the case of sample, it is statistic. Sample size is given by small n. Sample mean is denoted by x bar. Sample SD is denoted by S, and sample proportion is denoted by P. So we have to remember, because then only we will be in a position to apply different formulas and different conditions to solve and to understand the problem. What is the need of sample? Time taken for the study, cost involved for the study, physical impossibility of complete enumeration, practical infeasibility of complete enumeration, enough reliability of references based on sampling, and quality of data collected. What are different types of sampling? There are two basic types of sampling, depending on who or what is allowed to govern the selection of the sample. First one is probability sampling. Each element in the population has some non-zero probability of getting included in the sample. And non-probability sampling, it may be picked up based on the judgment or convenience of the enumerator. What are the methods of probability sampling? Simple, random sampling, systematic sampling, stratified sampling, and cluster sampling. So we will be discussing a little bit about all the four. Under simple random sampling, each element of the population has an equal probability of getting included in the sample. All other forms of probability sampling use the basic concept of simple random sampling, but applied to a part of population at a time and not to the whole population. Probability in general, there are NCN, small capital N, C, small n, different samples of size n that can be picked up from a population size of n. That means that is how thing can be picked up from a large volume. Simple random sampling ensures that any of these samples has the same probability of picking, that is 1 upon NCN. Systematic sampling. This sampling proceeds by picking up one element after a fixed interval depending upon the sampling ratio. For example, for a sample of size 10 from a population of size 100, the sampling ratio will be 1 by 10, which decides to start from among the first 10 names in our frame. If this number happens to be 7, for example, then we will start with 7, 17, 27, and till 97 in the frame. Stratified sampling. The basic idea behind the stratified sampling is to divide the whole heterogeneous population into smaller groups or subpopulations, such that the sampling units are homogeneous with respect to the characteristics under study, with the subpopulation, and heterogeneous with respect to the characteristics under study between or among the subpopulations. Such subpopulations are termed as strata. Treat each subpopulation as a separate population and draw a sample by SRS from each strata. Stratified random sampling is a method of sampling that involves dividing the population into small groups, which is known as strata. The groups of strata are organized based on the shared characteristics of attributes of the numbers in the group. This process of classifying the population into groups is known as stratification. You can see in this diagram, this is S1, S2, S3, what means three strata have formed. Now, to understand what we said just right now, suppose you have stratum 1, 2, 3, and number of elements, that is Ni, is 200, 300, 500 respectively. And the sample size, that is small ni, 10, 15, and 25. Then its sampling ratio will be 10 by 200, 15 by 300, and 25 by 500. So that means the sampling ratio will be same, 1 by 20, 1 by 20, and 1 by 20. The whole system can be depicted on this figure. That means N1 by N1 is equal to N2 by N2. And in the last, we can see that if we divide 50 by 1000, we get 1 by 20. That means all the sampling ratio values are same. Disproportional stratified sampling. If the different strata in the population have unequal variance of the characteristics being measured, then the sample size allocation decision should consider the variance as well. It will be logical to have a smaller sample from the strata where the variance is smaller than from the another strata where the variance is higher. Now we can say over here, if sigma 1, sigma 1 square, sigma 2 square, sigma 3 square, and sigma n square are the variance of the strata respectively, then their efficiency is highest when n1 upon n1 sigma is equal to np upon nr np. This has been transformed into the same problem. Here, stratum as d is there and sample size and the stratum variance has been calculated. So when we are finding out the sampling ratio, we are finding it out all the three values are different. And if we find out the ratio of 50 by 1000, it is again different. That means this is an example of disappropriate sampling. Now, what is cluster sampling? A colony is divided into 11 blocks, each block A through to K. Cluster sampling is used in this situation by treating each block as a cluster. Two blocks are selected out of 11 blocks at random, and the information is collected from all families residing in these two blocks. And we presume that whatever the information is collected from two blocks will be applicable to all remaining 9 other blocks. What is the comparison between cluster and setup? Cluster are homogeneous within the different from other strata. Cluster should be heterogeneous within, and the different clusters should be similar to each other. A cluster is a mini population and has all the features of the population. The criteria used for stratification is a variable associated with the characterized measure. Convenience of data collection is usually the basis for cluster definition. There are very few strata, but there are many clusters. What is multi-stage and multi-phase sampling? multi-state sampling, where the sampling unit is something larger than an individual element of the population in all stages at the final. And multi-phase sampling, it is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with two phases is often called double sampling. Convenience sampling. In this type of non-probability sampling, the choice of the sample is left completely to the convenience of the interviewer. The cost involved in picking up the sample is minimal, and the cost of data collection is generally low. For example, the interviewer can go to some retail shops and interview some shoppers while studying the demand of non-eradicated beverages. What is meant by purposive sampling? In convenience sampling, any member of the population can be included in the sample without any restriction. When some restrictions are put on the possible inclusion of a member in the sampling is called purposive. Judgment sampling. In judgment sampling, the judgment or opinion of some experts forms the basis for sample selection. The experts are persons who are believed to have information on the population which can help in giving us better samples. Such sampling is very useful when we want to study rare events or when members have extreme positions or even when the objective of the study is to collect a wide cross section of views from one extreme to the other. Quota sampling. When we are using non-probability sampling, we might want our sample to be representative of the population in some defined ways. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. For example, size could be another criteria, and we want to set quotas for families with family size up to 3, between 4 and 5, and above 5 children. However, if the number of such criteria is large, it becomes difficult to locate sample members satisfying the combination of the criteria. One of the most important factors that affect the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, that is, if all the members of the population are exactly identical, a sample of size 1 is as good as sample of 100 or any other number. Second consideration is the confidence in the inference made. The larger the sample size, the higher is the confidence. In many situations, the confidence level is used as the basis to decide sample size. Now we move on to sampling distribution. In general, sampling distribution of a given statistic is the distribution of the values taken by the statistics in all possible samples of the same size from the same population. In other words, if we repeatedly collect samples from the same sample size from the population and compute the statistic, mean, standard deviation, proportion, and then draw a histogram of these statistics, the distribution of that histogram tends to have is called sample distribution of that statistics. Sampling distribution of means and the central limit theorem. Under this, we assume that start with normal population. Let X be the sample mean of the random sample of size n drawn from a population having mean m and standard deviation s. Then x bar will be equal to mu. The mu x bar from the mean will be mu, and the standard deviation will be sigma upon under root n. After selecting a sample, one would like to go for estimating the value of a population parameter. These are the steps which normally comes while we are calculating things or we are thinking of calculating something. Testing a statistical hypothesis under the population and comparing two or more populations, performing correlation and regression analysis. Sample statistic is a function of n sample values x1, x2 till xn. A sample statistic is a random variable and therefore has a probability distribution or a probability density function, that is PDF. It is also known as sampling distribution of the statistic. Sample statistics from the basis of all inferences draw about the population. That means sample statistics is one of the important tools draw and inference. Probability distribution of sample statistics allows us to calculate the probability that the sample statistics assumes a particular value. This ability to calculate the probability that the sample statistic lies in a particular interval is the most important factor in all statistical inferences. Now, how to calculate all these values what I had discussed right now. Suppose the sample is x1, x2 till xn. Sample mean, as we know, is summation of all the terms upon number of terms. So that means in this case it will be x1 plus x2 plus till xn upon n. For another sample of size n from the same population, we might get a totally different set of sample values and so a different sample means. That means we will be getting two means. There are perhaps infinite possible ways of the sample. What are the different formulas of the condition to calculate all these values? And we will start with sampling from infinite population. Population is very infinitely large and its mean is mu and the standard deviation is sigma and the sampling is without replacement. So as T of the sample mean is also called the standard error of the mean. So expect your mean will be equal to E x bar equal to mean and its variance will be sigma square by n. The standard error of the mean indicates the extent to which the observed value of sample mean can be away from the true value due to sampling error. So that means in that case we can calculate standard error of the mean is denoted by sigma x bar and is equal to sigma upon under root n. If the sampling is from finite population, the population is finite, population mean is mu, and population variance is sigma square, and the sampling is without replacement. The random variable do not remain independent. In this case, there is a change in the formula. E x bar is equal to mu, and its variance will be sigma square by n into n minus n upon n minus 1. And the standard error of the mean will be sigma x bar equal to sigma upon under root n into under root of n minus n by n minus 1, where this n minus n upon n minus 1 is called the finite population multiplier. If the sampling is done from normal population, so x tends to n mu sigma square, which follows that it is approaching n square by n. The normal distribution is a continuous distribution, and so the population cannot be small and finite if it is distributed normally. We take up an example to understand. Suppose the diameter of a component produced on a semi-automatic machine is known to be distributed normally with a mean, that is mean, 10 mm and the standard deviation of 0.1 mm. If we pick up a random sample size of 5, that means your n will be 5. What is the probability that the sample mean will be between 9.95 mm and 10.05 mm? So when we are just depicting all these values in our standard formula, so we get probability of minus 1.12 should be less than z should be less than 1.12. Since this is symmetrical, so we will be finding out the value of 1.12 only and we will be multiplying it with 2 because We have to calculate the area under the curve on between minus 1.12 and plus 1 point. That means that is symmetrical. So we will be finding out the value of, let's go, at 1.12, and we will be multiplying it by 2. That means 0 into 0.3686, which comes out to be 0.7372. That means probability that the sample size will be between 9.95 and 10.05 mm is 0.7372, that means 73%. This is how it is written on a normal curve. When we move to central limit theorem, if x1, x2 till xn are the n random variables which are independent and having the same distribution with mean, mu, and standard deviation sigma, and n approaches to infinity, the limiting distribution of the standard deviation will be z equal to x bar minus mu upon sigma upon under root n, and is a standard normal variable. Earlier in normal distribution we were using z equal to x minus mu upon sigma. So there is a slight change. A sample size larger than 30 is generally considered to be large enough. We have to keep this thing while we are working on sampling, that the figure should be compared with, sample size should be compared with 30. We move on to standard T distribution test. In actual practice, the value of the population standard deviation sigma is often unknown, which makes it necessary to replace this with an estimate. Usually, S, the sample standard deviation, is taken. We were having the formula x bar minus mu upon sigma divided by under root n, which can be transformed as x bar minus mu upon s divided by under root n. Exact sampling distribution of this is given by T distribution. That means value of x bar minus mu upon s upon under root n. Student T distribution. If x is a random variable having the standard normal distribution and y is a random variable having a chi-square distribution with v degree of freedom, and x and y are independent, then the random variable is given by t equal to x upon under root v minus mu, and has a distribution called T distribution or the student T distribution with v degree of freedom. With this, I will be concluding today's session, and we will be meeting on Monday, and we will be continuing to this. हाँ हाँ, कितना बढ़ा दिया भैया आज तो, अब इसके अगले 2 वाले में मजा आएगा।